This section is talking about sketching graphs of polynomial functions. We've previously done different types of graphs with linear and quadratics. This particular section deals with cubics and quartics. However, we do need to do a little bit of revision first. So, we have different types of graphs, and the highest power determines the shape of the graph. So for example, if I did x plus 1, the highest power of x in this particular graph is our x. So then, that means we have a degree of 1. Now remember, when you have a degree of 1, it can either be positive or negative, like so. We can also have something like this, which is negative x squared plus 3x minus 2. Our highest power on here, okay, is our x squared. So, because our highest power on here is x squared, we have a degree of 2. Remember, degree of 2 means we have a quadratic, and quadratic means we can either have a shape like this, or a shape like this. So, for x-intercepts, remember when we're solving it, we need to sub in y equals to 0. And for y-intercepts, we then need to sub in x equals to 0. For our stationary points, the first one that we've learnt is turning points. Now, stationary points, if you recall, on a turning point, we had the graph not going up or down on a certain section. So, for example, we had this, and that was our turning point, because it wasn't going up or down. So, this particular turning point occurs when we have graphs with degree of 2 or higher. There is also another one which we are going to add in today, which is called a point of reflection. No, sorry, point of inflection. And this particular one pops up when we have a degree of 3 or higher. So, this will become a little bit more evident when we go along, particularly this point of inflection. So, as a bit more revision, we have a turning point form. So if you remember your quadratics, we had y equals to a bracket x minus h all squared plus k. And in particular, our h, k is where we have a particular turning point. We will need this later on, so don't forget it. So, we are doing cubics and quadratics. We are going to start with cubics first. So, with cubics, there are two basic types. We're going to start off with the most common one that you will see, in which the positive one has a shape that does this. If it's negative, then we would have a shape in reverse, which does that. However, you may also sometimes see one where you have a flat bit in the middle, in which for positive one it will look like this, and you have a flat bit in the middle like that. Okay? And for the negative version, it goes the other way. And there's your point where it goes flat. This particular flat point is one where we have a point of inflection. And this normally appears when you have an equation that looks like this. Notice that the equation that we have looks quite alike with the turning point form of a quadratic, except for the fact that there is a cube right there. Other than that fact, it looks exactly the same. So, when we're graphing, just as a reminder, we need to determine the shape. We need to determine whether or not it's positive or negative. And we also need to determine the degree of the polynomial. Should all be basic stuff. Degree of polynomial, we can have, in this case, a cubic, a quadratic, and sometimes even a quartic or a linear graph. And remember, it's all determined by the degree of a polynomial, aka the highest power. And don't forget to check if it's positive or negative. We can find our x and y intercepts, and we also need to put points in and sketch. So we should always put the points in before we sketch. I know it doesn't look as nice, and I have been telling you guys that if you do know the shape, it is nice if you actually sketch it first and then put the points in. But for starting off, we should just put the points in before we sketch. That way, we know what we're putting in, and then we can check if it makes sense or not. So, let's do an example. What we need to check first on the example, is see that they are all in brackets. If they're all in brackets, we won't know what the polynomial is until we multiply it. So as you can see, I put in arrows. I put all the x's in arrows, because when you multiply all the x's together, you have your degree. So we have an x there, we have an x there, and we have another x. What we're going to do, we're going to multiply them. X times x times x, that should give us x cubed. This then says that that is a cubic, and then this then says that it's positive. So that means we have a positive cubic. And if you need to remind on the shape, I'll put it on the bottom. The shape is positive, and it's a cubic, so it should look something like that. Now, because they are all in brackets, we can solve for the points using the null factor theorem. If we're using null factor theorem, then you should get the x-intercepts as I've listed there, which is -5, 0, -1, 0, and 2, 0. So let's put those points in. We have -5, 0, which is less than -1, and then we have a 2, 0 right there. And then, last but not least, we have a y-intercept of 0, -10. And so put that point in. Okay, so we want it to look like the graph below, so we're going to start from the negative end and go up. I might actually use a red for this. I'll use a green actually. We're going to start from the negative point, and we're going from the bottom upwards, like that. Now, if you notice, it's going to curve back around, and that's the only way it will fit onto the other point. So it's going to curve back around and go down. And then, notice that as it goes down, it curves back up again. Okay, so we're going to make it go down and curve back up again. And then it's going to go straight up. I know mine looks a little clunky, but I'm sure you can fix it a little bit and make it look a little bit better on your own paper. I am using an iPad after all. Put all the values in, don't forget that. And we should always label the graph. So there's the full graph. Make sure you put the points in and then you sketch it. So, next example. We're going to do the same thing, except notice that this time we have a square on the top. If I can circle it or underline it. Because we have a square on the top, this time when we put it down here, we need to have x squared, because remember, you have two brackets that are going to be the same. Those x's are going to multiply to give us an x squared. And then, over here we had a negative x. So we're going to multiply that negative x. So then we get a negative x cubed. This time, that negative tells us, obviously, that it's negative. And because it's x cubed, we are going to have a graph that has a shape that goes down like so. Now let's have a look at the x-intercepts. When we solve for the x-intercepts, notice that that bit has a square on it, the section on the left. If when you are solving there is a square on it, that says that this has a turning point. Because there is a turning point, when we put it into the graph, which I'm going to put it on the right now, on the turning point, which is at x equals to 1, it's either going to go down and then back up, or up and then back down. But it's never going to ever cross that particular point there. Now, we are having a graph that goes from the top to the bottom. So on the left, we are going to have a high point going downwards like so. It's going to go to x equals to 1, and because it's a turning point, it's going to turn back up and then go back down like so. So then we have 0, 2 there, we have 1, 0 there, and we have 2, 0 there. Last but not least, label the graph again. Do not forget to do that. I like blue, so I'm going to use blue again. And there we have it. Make sure if you have a turning point that this particular section here is a turning point, so that you don't have any points crossing over. So, for quadratics, we have multiple types. Notice that the first one looks, not quadratics. That should not say quadratics, that should say quartics. And I can't spell today. I apologize for my handwriting. So, for quartics, notice that the first one looks like a quadratic. This appears when we have y equals to something like a turning point form, except this time it's a power of 4 plus k. So this has a turning point at hk as per usual. The other two after that are quite common. They have some funny shapes. They go up and down. If you look at the last one though, notice that there is a point of inflection. Because there is a point of inflection, we then should assume that the graph has something that looks like this. Notice that there, on this one, has a cube, and on this particular one, it has a power of 4. Otherwise, we solve the rest of them like normal. So, as per usual, the steps are still exactly the same. We take the highest power, in which we have an x there, but that's cubed. If I can highlight it. Okay, so that's x cubed, and that has an x in there, so we multiply by x, and so then we have x to the power of 4. Now, on the x-intercepts, if you have a look, that has a cube right here. That cube then says that we have a point of inflection, sorry. So this has a point of inflection. Whether or not it goes up and down is determined by this particular bit here. So, because we have x to the power of 4 and we have a point of inflection, we will presume that it looks like the bottom graph on this particular page. Now, let's put that point in, just to remind ourselves of where it is. And then, we also have a y-intercept of 0 and negative 32, so let's also put that in, which is right there. So, because this is positive, and we know that there is a point of inflection there, then we can presume that we have a shape that looks like this. So, let's put that in. This is a point of inflection at x equals to negative 2, and so we'll go from the top, put that point of inflection in, go down towards our y-intercept, and then we're going to go back up through the other point. And that was negative 2, 0. That there was 0, negative 32. And that there was 4, 0. And so there you have it. We'll just label the graph again. So, last example here. We have y equals to negative bracket x plus 3 squared bracket 2x plus 1 squared. This time around, if you have a look, we have a negative there, so we need to put that negative in. We have x squared and 2x squared. Now remember, it's 2x all squared, not just 2x squared. And if you multiply that out, you should end up with negative 4x to the power of 4. Because that's negative there, we have a negative graph. And so you will presume it's upside down. Now, this time around we have a squared there and a squared there. So these two are now turning points. So on the particular value which I'm going to put on the graph, we have negative 3 and we have negative 1/2. These two are turning points. Because they're upside down, we know they're going to have a shape like this. And if you have a look, because these two are turning points, the only points where they can fit are there and there. So, if you join all of this together, then you would have this particular graph here. we have the turning point over here, and turning point over here. Actually, let me rub that out first, because this is getting messy. Oh, there's an orange. Let's do orange. You would have turning point there, turning point there, and we can go down right there. This had a value of -3, 0. This had a value of -1/2, 0. And that was 0, -9. And so our graph was y equals to negative x plus 3 squared to x plus 1 squared.